about this problem?
They have two tangents
I mean,
inverse.
it's so close. Yeah, but yeah, we need a reciprocal, but the sign's wrong. Okay, excuse me. Okay, there are two ways we can do this one. We can work it and leave it as secants and tangents and get there. Or I can change it to sines and cosines and then essentially do the same process. So you all tell me which would you... Yeah. Yeah, well, actually, in this case, it would be messier to do the fractions. Okay, this is a sneaky, mean little trick. But essentially, you notice these two are kind of conjugates of each other. Secant minus tangent, secant plus tangent. You can't multiply to the other side. You can't move it across. But that's actually often a hint or an indicator. If you see that you have they're conjugates, okay, I can only work on one side, so I'm going to multiply it by its conjugate. Why is this going to work? What's going to happen on top?
It will get squared, but you use the formulas and cancel them out.
Yeah. Because isn't it going to put what I want on top? What I'm trying to get equal to? So by using that conjugate, well, I got what I wanted up there, but I'm still stuck with the whole bottom. Okay, do I want to leave the bottom in its separate factors, or should I FOIL it together? Since they're conjugates, FOIL it together. If they're conjugates, FOILing it together will help you. If they weren't conjugates, I would not FOIL it. Okay, so once again, when I FOIL it, though, I'm going to get a secant squared, but what's going to happen to the middle terms? They're going to cancel, and so I'm going to have minus then tangent squared. Okay, now, warning bells are going off, lights are flashing. Why is it 1? Yeah, it's number 7. You got squares in there. If I take number 7 and make it, say, secant squared minus tangent squared, if I subtract the tangent squared over, it's going to be equal to 1. And therefore, I can wipe the whole denominator out. That whole denominator is equal to 1, and I'm now equal to each other. If you see that happening. So, if you look like you might have conjugates involved, try it. Conjugates can help a bunch. That is going to be one of our tips, yes. So, if we had done that with sines and cosines, we'd have gotten there, but we'd have done a whole lot more work. Okay. I forget how I phrase this. How do I say that? This is a hard one to phrase and have it make sense. All right, if you just need to think conjugates. They just happen. Right.
Exactly something that's got like a fourth power and a square.
Yeah, if it was sine squared and sine to the fourth, you can pull a sine squared out. So you look for common factors you can pull out.
Okay.
That could happen.
Oh, but it's 2. Let's say it's 2 times squared.
Okay, and I'm going to add one more on here. My last one, and this is kind of just a general one. If you're debating about particularly if there's more than one identity that might work, using an identity that will make you have terms that will cancel is always a good choice. The more you can cancel and reduce it down, you want to. So if in doubt, always pick something. If there's a choice about making some terms cancel out, use that identity. It'll help you. The more you reduce, the better you get. Okay, I have one other minor little thing to say to you. You have at the very, very end of this assignment, you have a problem that says verify using your calculator. Oh, yes, you can. And with these calculators, it's now easy pud. Before it was a pain. Now it's easy. Because now you guys have, my old calculators did not have secant, cosecant, and cotangent. These calculators have them. So this will be simple, simple, simple for you all to do. Okay, if you're going to verify it by calculator, and by the way, these are the only ones, they're asking you yes or no, is this an identity? So these could be no, they may not be equal. But how on earth could I have you verify it by a calculator?
Are all your verified going to come out yes?
Nope, because you're not going to have a number if it's something like this.
Ms. Meyer, do all your verified by hand come out as
Yes, all the verified by hand work.
Okay, well,
They will equal. They all work. There's none that don't work.
How long's their homework take? It's going to take a long time?
No, because we're about to start working on these. Okay, if I said verify this, how would you verify it? Put it where in your calculator? Nope. In the graph. What you do is you simply put this side in F1, put this side in F2. If they're equal when it graphs them, what should happen? They should be the exact same graph. Now, make sure you are in radians. You have to be in radians, that's important, when you graph it. But you literally just have to punch that in your calculator and let it graph both of them. You should see it graph them, the exact same graph twice. They should be, if they are not the exact same graph, it's not an identity. No. You cannot do anything across the equal sign.
On the verify by calculator, you will have one too, yes.
Yes, on the graphing, it could be yes and no. Everything else, by hand, always works. Guaranteed. Still always works. Okay.
whenever you get done, can you check my